to be 3/2 cubed. Remember, this is an absolute value, so the negative will become positive. 3/2 cubed is 27/8. That's greater than 1. Therefore, it diverges by the root test. Okay, let's do another one. Oops, the bottom got cut off there. But that is the sum as n goes from 0 to infinity of e to the negative n. So once again, we'll take the nth root. The limit as n approaches infinity of the nth root of the absolute value of e to the negative n is the limit as n approaches infinity of e to the negative 1. Again, I got rid of the absolute value bars because given the parameters, this was always going to be positive. That's 1 over e. 1 over e is greater than 0. Therefore, it converges actually absolutely by the root test. So a couple of guidelines now that we've gone through the different tests for convergence and divergence. Remember, the only test that actually tests for divergence is the nth term test. The nth term test does not tell us anything about convergence, but it can tell us if a series diverges. So the first thing you could do is determine whether the nth term approaches 0. If not, the series diverges and we're done. That's probably the easiest thing we can do. Then we want to look and see, is the series one of the special types? Geometric, p-series, telescoping, alternating, something like that. If so, perform that test. Then look, can the integral test be used? So do you know how to integrate that? What about the root test or the ratio test? Do any of those look like they would apply? If so, use them. And then if nothing else seems to work, comparison tests tend to be your kind of last-ditch effort. So can a series be compared favorably to one of the special types? So that's the end of the different tests for convergence and divergence. You'll be tested on all of these different tests, and then we'll jump into Taylor and Maclaurin series next.